evaluate the alternating harmonic series. So 1 minus a half plus a third minus a quarter, you get the idea. And we're adding up that particular sequence. Now, how can we do this? Well, I mean, if we took enough terms, we could approximate it, but actually evaluate? There's only a few ways to evaluate a series. If you've got some partial sums, that works. If it's geometric, if it's telescoping, or if you can recognize this as a particular value of a function that can be represented by a power series. So if we had some power series, and if you plugged in 5, this is what you would add up, then f at 5 would be what you need to calculate. So can we recognize this as power series? Well, let's take a look. Now, a lot of your more common power series have factorials along the bottom. We don't have that here. Okay. We could rewrite this first one as 1 over 1. Okay. But we see we've got over 1, over 2, over 3, over 4, over 5, over 6. Can we think of any power series for functions that we're familiar with that work this way? Well, yeah, ln 1 plus x. And it looks like x minus x over 2, x squared over 2, plus x cubed over 3, minus x to the 4th over 4, and so on. This is exactly what we need, the over 1, over 2, over 3, over 4. Now, how do we get the numerators to match? Because notice also that the signs here match. Well, on top we just get 1s. So I suppose if we let x equal 1. Okay. Now, think about this. Do we actually know that we can plug in x equals 1? You should always think before you just plug in, because it looks like the answer is probably going to be ln 2. Right? Because if we put in x equals 1, then we get 1 minus 1 squared over 2 plus 1 cubed over 3. And so that would work, but does this make sense? Okay. Well, remember that ln of 1 plus x has an interval of convergence. The minus 1 isn't included, but the 1 is. So we use a square bracket. And what does that mean? That means we can actually plug in x equals 1 and it will all work out. So yeah, we can evaluate this, and the value is just ln 2, which if I recall correctly is 0.6923, something like that. Okay. Well, there we go. So we just had to analyze our series and match it to a power series at a specific value, and then we had to double check that that makes sense.